All right. So adding probabilities, kind of the next step, a little bit of a baby step again. I don't know that anything on here is going to be the types that I expect on your regents, but again, you need these basics to work your way up to what we will expect on the regents. In this first exercise, consider the spinner shown that has been divided into 8 equally sized sectors of a circle. The spinner is spun once. In this experiment, we will let A be the event of it landing on an event, and B be the event of it landing, not on an event, on an even. So A is on an even, circle that. B is it landing on a prime. Okay? That's set B. Sometimes when we introduced Venn diagrams on Friday, we filled in the Venn diagram with just the number of the total number of elements in each section, which is the traditional way of filling in a Venn diagram. This, however, does say to fill in the Venn diagram with the actual numbers from the spinner. So, like we should with Venn diagrams, we start inside out. So, we want to start with the overlapping section. That's just the way you should start Venn diagrams. So, what numbers are even and also prime? What numbers classify as both? The number 2 is even. It's also prime. Anything else? Good. There isn't. So I'm putting 2 there, not because there are 2 elements that fit that category, but because that is the actual element 2. What numbers are even? 2, 4, 6, 8, but 2 is already in the even circle, so I'm not going to relist that. I'm just going to do 4, 6, and 8. So I'm just having those actual numbers float around. And what numbers are prime, Riley? 2, 3, 5, and 7. Very good. 2 is already in the prime circle, so I'm not going to recount that. But 3, 5, and 7 I'm going to have floating around. Okay? What number has not, or what numbers have not yet been accounted for? 1. And that's it, right? Everything else has a spot. Where do I put 1? On the outside. Very good. Okay? Just for the sake of making sure we have it, because it is the more traditional way of doing a Venn diagram, typically you would put the tally of how many items are fitting within each circle. So there's 1 item in the overlapped region. There are 3 items in the A but not B. There are also 3 items in the B but not A. And then there's 1 item on the outside that belongs to nothing. So this is the tally method, more common, but here they just did say actual numbers. Okay? Now, a little bit of notation. Union and intersection, okay? The symbol for a union looks like a U, so that's pretty straightforward. The symbol for an intersection is an upside down U. Okay? A union, when they ask you for the union, and this would be the notation here, A union B, that is uniting. Think union, think uniting. That is uniting the set. So that's anything that's in A or B is going to be in the set A union B. Okay? So right now, our set for A union B is all of these numbers, 2, 3, 4, 5, 6, 7, 8. Okay? That's the union, the uniting of sets A and B into a larger set. Okay? Versus the intersection, and you see how they kind of punched out that overlapping shape right here? I don't know what you call that shape, a little football. They kind of cut that out. This intersection, if you want the intersection of set A and set B, the intersection is the overlap. Okay, so that's the overlapping. Elements. So in this case, that's just 2. That's just the number 2 that is in both sets. Okay? That notation is tough. I'm not sure how often it's going to come up. I think it came up on one question. My fear is that it comes up and that we just don't see it often enough to remember it. So if you can just remember union with the U and kind of uniting, uniting, using an or, okay? And the flip of that, intersection, is where they overlap and uses the word and, because it would have to be in both. If it's in A and B, it has to be in both. So that's your intersection. Okay, so what I just talked about, we'll just write down in A or B. If you want to write out the following set of what is in A or B, this is A union B. And we're going to write out this set. It's 2, 3, 4, 5, 6, 7, and 8. Whereas our intersection is just 2. That set only has one item in it. Okay? Some notation that this probability chapter uses, again, I have not seen this notation on the Regencies yet, but the textbook that we sort of use does use it, and could they do it? I guess. I don't know. Sometimes the notations don't line up. But this is just meant the number of items in A or B. Okay? So the number of items in A or B are 1, 2, 3, 4, 5, 6, 7. We just count them up. This would equal 7. And also, it wants us to evaluate them separately. What's the number of items in set A only? Chance?
3.
No. Look at set A. How many items are in
4.
set A circle?
Yeah, 4.
Okay, good. So you just didn't count that one, but that one's technically in set A. So this one would be 4. And Cole, how many items are in set B? Also 4. So how come that is different? Right, because this one counted the number 2 twice. It's that whole double counting thing. So the point I think that they're trying to make here is that the number of items in A or B will equal the number of items in A minus the number of items in B, or plus the number of items in B. But you have to subtract the overlap. So that is us, we're going to have to subtract the number of items that were in the intersection of A and B. So that 7 would equal 4 items in A plus 4 items in B minus that one item that was in both A and B that got double counted. So again, back to that or, meaning addition when it comes to probability. Or should equate with addition, but you do have to remember always to subtract things that might have been double counted. Okie doke? Okay. Any questions at this point? All right. All right. Two-way frequency tables. This will be on your Regents. Okay, I would bet. And knowing how to read these. So two-way frequency charts, and you're going to kind of take a look at this one. We're looking at two different variables here. The first variable is whether or not someone goes to college. And the second variable is gender. And we're going to start to take a closer look at do those two things affect each other or not? Okay? Does your gender have anything to do with the likelihood that you'll be going to college? And that's the kind of thing that we'll be able to look at from some of these tables. So you'll notice in the male category there's a total of 30, 16 who went to college and 14 who did not. In your female category, we have a total of 22 that we've talked to, 13 of whom went to college, and 9 of which did not, okay? Which made a total of 29 who went to college, 16 were male, 13 were female, and 23 people who did not go to college, 14 who were male, 9 who were female. And then these totals, your male and female total is 52, should be the same as your going to college, not going to college total, which was 52. So there were 52 people surveyed, okay? And then we broke them down into gender, and we broke them down into going to college, not going to college, okay? But there were 52 people total surveyed. So here's our data. There are 4 categories given to us by a capital letter, just so we don't have to write so much. And here's that N notation again. So what was our number of males, Jake Clancy? 30. Molly, what was our number of females? 22. What was our number who went to college, Margaret? 16. No. Going to college. You just gave me the number of males you just gave me the number that was male and was going to college. You gave me this number, right? That's the number of people who were male and going to college. We want just the number going to college. So that's just our total here, 29. And Morgan, our number not going to college, 23. Okay? So now we get the and the or thing going on here. What was the number of people who were male and going to college? That's what Margaret had originally given us. That's the 16. Those are your males who went to college. So that's 16. The number of females who went to college, Hunter? 13. And what is our number of people who are either female or going to college? Now this gets tricky here, because there's that or piece. How many females do we have, Cole? How many females? 22 females. You just gave me the females who were going to college, okay? But as far as, you only need to be one of these things. You either need to be female or you need to be going to college, and if you're just one of those things, you're included in this number. So we need to include all of our females, which is 22 of them, plus we need to include all the people who went to college, going to college, 29. But what do we have to remember to do? Right, we definitely counted some people twice. The females who are going to college have been counted twice. They've been counted in the female category. They're in this total of 22. And they've been counted in the going to college category. They're in this total of 29. So we need to subtract the number that are doing both. So the intersection of female and going to college. So that'll be 22 plus 29 minus how many people are females and going to college? 13. So this will give us our total number. 22, 32, 42, 52, 51. 51 minus 13, 38. So again, with that or, making sure we're being careful of subtracting any double counted people. Okay? So now, with the frequency, that's just giving you the basics of a frequency chart. We're going to be asked a lot about probability and the information we're going to have to extract from a chart. So what is the probability that a person picked at random would be a female who is going to college? Okay? So we want the probability of being a female and going to college. So how many people are female going to college? 13. So our probability is 13 out of 52. And I represented it with an intersection because we wanted that and. Okay? What is the probability that a person picked at random would be female or someone going to college? So here this is the union, probability of being a female or going to college. Now the good news is we already know that number. How many people are either female or going to college? 38. We already calculated that above, which was the hard part. So there are 38 out of 52 people that would fall in that category. Okay? And then just an explanation of why the probability of female or going to college does not equal the probability of female plus the probability of being in college. We already said it's because this one double counts, okay? This double counts the 13 people who are both female and going to college. Does that explanation sound good to you? Okay.
What does that word say? This what?
This double counts. So the general probability rule, law, I would say, that we've talked about actually over the past couple days, we'll just fill it in. If you want or probability, we need the probability of the first event plus the probability of the second event minus the probability of, and on the first day we wrote both, but here, because we're using a little bit more of mature notation now that we know it, I'm going to subtract the probability of the intersection. That means the probability of both. Okay, and that's the general law with or probability, which we've been talking about since day one. Any questions? Okay. Exercise 5, standard 6-sided die. So I'm just going to write the sample space, 1, 2, 3, 4, 5, 6, just to help me wrap my head around what's going on. Remember, that's the key. Reading slowly, taking your time to wrap your head around what's going on. Find the probability that the number rolled was either an even, so we're looking for the probability of even, or a multiple of 3. So using our law, we want the probability of even plus the probability of being a multiple of 3, I'll write M3 for short, minus the probability of both. Tyler, what's the probability of being even?
3.
Very good. Yeah, we'll reduce later. I actually don't want to reduce this early on because I might change the denominators, then I won't have a common denominator for addition anymore. So I won't, do the same work twice. Probability of having a multiple of 3. Chance? 2 out of 6. 2 of those numbers are multiples of 3, the 3 and the 6. And what numbers are both? What numbers are both even and multiples of 3? There's only one number that is both of those things, and that is the number 6. So we have to subtract 1 out of 6 of these that was double counted. So See what I mean? Now they all already have a common denominator, so we can just do 3 plus 2 is 5, minus 1 is 4. So your answer is 4/6, and then reduce to 2/3. Okie doke? Okay. All right, exercise 6. This looks like more like a Regents question to me. Exercise 6 says insurance companies typically try to sell many different policies to the same customers. Fluff, right? We can read into that and be like, okay, that's just giving you some basic context. At one such company, 56% of all of the customers have car insurance. 48% have home insurance policies, and 18% have both. Okay, we need a visual. What visual is going to be helpful here? Venn diagram, okay? Visuals are huge in probability. So give yourself a Venn diagram. And this is at one insurance company. What insurance companies do you know of? You're too young for that. Come on, you see commercials. Allstate. This is Allstate. And Allstate says that 56% have car, so I'm going to have a car circle, and 48% have home. Go ahead and fill this in on your own to the best of your ability. You don't need to necessarily find the answers to the question yet, but I just want you to organize this visually. Alexis, what did you have in your 3 bubbles? Okay. Does anybody have anything different? Sarah. Raise your hand if you had what Alexis had. These 3 numbers, 56, 18, 48. Raise your hand, straight elbows. Okay, she's got supporters. She's got 1, 2, 3, 4, 5. Raise your hand if you had what Sarah has. She's got... Hunter, did you raise your hand for both people?
I thought you were.
Okay. 1, 2, 3. So she's got a few more supporters, and then some people didn't raise their hand. Raise your hand if you didn't raise your hand because you don't agree with either of them. Or because you're not sure. Now you've gone radio silent on me. Not everyone voted, but I'll tell you what. Alexis, look at your numbers. How many years are these numbers, the top version, right? How many total are in your car category? 74. Was that supposed to, did 74% of people get car policies? No. Okay? Only 56 were supposed to get car policies. So your 2 numbers within the car circle are supposed to add up to 56. And that's not uncommon, that number 56 is not going to show up at all. Not only that, but I'll say this. Alexis's three numbers, remember these are percentages. She's already got these adding up to over 100%. Right? So, that can't happen. What Sarah did, which is what I continue to encourage, is start with your both. Because you want to work from the inside out. So we have 18% in both. That's where we should start, and that's correct. You both agreed on that. Now, given that the car percentage was supposed to be 56, we have to figure out what is left to get us to 56. So these 2 needed to add up to 56, which is how she then came up with 38. Do we follow? Okay. And in the home category, we were supposed to add up to 48. The 18 is glued there, so she needed another 30 to make the 48 happen. Now, what do those percentages add up to? 68, 78, 86? Okay? So what does that tell us? How many Allstate, if these add up to 86%, how many Allstate customers have neither of these? 14%. So let's say they must have a different type of insurance, whether it be life insurance or, I don't know, long-term care insurance, whatever. I'm sure you guys know all about that. Mr. Weidman and I know all about that. Not really, but maybe more so soon we will. Yeah. Okay, so there is your Venn diagram. Now answering the questions should be a breeze. What is the probability that she or he has at least one of the policies? If you have at least one, which numbers are we looking at? Anything that's in the circle. All of these people have at least one. So that's 38 plus 18 plus 39. So, I'm sorry, 38, 18, and 30, 68, 78, 86 we said. So 86 out of 100, that's 86% of the people have at least one. Some of those have both. 18% of those have both. But 86% have at least one. And part B, find the probability that she or he has neither of the policies. What's that probability? 14 out of 100, which is 0.14 as a decimal probability, which is 14%. So 14% of their customers have neither of these types, they have some other type. Any questions?